Hope the screen is visible to you people. Is the screen visible?
Yes, sir.
Okay, quickly we'll have the revision of what we have covered in the previous classes, right? And then we'll move on to the next method, right? So already we have discussed, just I have a quick slide slow so that if anything is missed out, you can just catch it, right? So you can see here one expression is given which is in POS form, right? And how the grouping is done and how we got the answer, and that's what is shown. I hope it is clear, right? You can see again how the grouping can be done, just different ways in which how we can do the grouping that is shown here, because some of you are still not confident about forming the groups. That's why I am going through this slideshow. You can just have a look at it and see how we can do the grouping, larger groups, how they can be formed, right? So this is not allowed, diagonally not allowed. 0 and 1 should not be combined. Only two adjacent ones like this you can combine. Already we have discussed all these things. Just I am showing you once again. You should not form a group of 3 ones. That is not correct. Again, you can't form a group of 5 ones. This is also not correct. Which is the correct way and incorrect way is shown here. You can just have a look at it, right? You can see all these things are shown, like how we can do the grouping. You can form 2 pairs, you will get this answer, but instead of forming 2 pairs you can form 1 chord, because rolling is possible and you can get only 1 term like this. Like this is also correct, but this is not the optimal solution. To get the optimal solution you have to form the bigger group here, right? You can see here you can form one octet, and there is one single one remaining, but you should not encircle that single one. You can try to form a pair like this, right? This is the right way of doing it. This is again a wrong way, because some of you I have seen in the homework problem, if there is a possibility of forming a chord like this, you have formed 2 pairs. Now here instead of forming 3 pairs like this, you can form 2 chords like this. This is the right way of forming the groups, right? So to summarize it, you can see here when you are simplifying SOP expression, what you should do: no zeros are allowed, no diagonal elements are allowed, only power of 2 number of cells in each group should be taken, right? Then a group should be as large as possible. Everyone must be in at least one group. Overlapping is allowed, wraparound is allowed. If possible, roll and overlap to get the largest group you can find. Fewer number of groups are also possible, right? And this what. And then the next one is, so these are the examples. Again, already we have solved so many examples. You can just have a look at it, right? How you can form. Here actually what is done is 1 octet and 1 pair is formed. But instead of forming a pair, you can combine these two, one with this like this, and you can form a chord. That's what again I am repeating. As far as possible, you should try to form a bigger group by doing overlapping, rolling, folding, all the operation. Here also you can see isolated and 1 pair. This pair can be combined with this to form a chord, and this isolated one can be combined with the all 4 corner ones to get one more chord, instead of going for isolated one and a pair, right? And I think some of you are having a difficulty. If suppose if you get isolated one like this, how this should be represented? You can see this one is common for this row as well as this column. So you should take A B bar, C D bar. That's what is taken here. Actually, this is not the correct way, but if you find isolated one, you should do it like this, right? But the actual you should form like this is also not correct. They form a pair. Instead of pair, you can go for the what? Octet. You can see there are 3 different solutions for the same problems given here. I'm not telling that the first one is wrong or the second one is wrong. Yes, first one is also correct, second one is also correct, but they are not the optimal solutions. Whereas the third one is the optimal solution for this. So you can see here how you can do the groupings, how grouping should be formed, right? So here this one and this one, actually it is just missing here. Here also you have what is that? So here also there is, here actually it should be like this also along with this, right? I hope it is clear, this particular example. Is that clear?
Yes, sir.
Three different solutions are there, but which one is optimal here? This is the optimal. So you should go for the bigger groups, should not go for the smaller groups, right? Now you can see here, this is also one more very important example, how grouping can be done. You can see here we have done this one group, then this. But now what is happening is, in this process, you have formed here one pair, this is one pair, second pair, third pair, fourth pair. All these fours are compulsory. But in this process, what is happening? The bigger group, the chord which you have formed, all the elements of the chord are covered in these four pairs. So that becomes redundant. Now this group becomes redundant, which is not required. So such redundant group should be eliminated. Is this clear? This is also an important example. No doubt you have formed one chord and four pairs, but when you form these four pairs are essential. Whereas this one is not essential. This is redundant now because all the ones of this chord are covered in the four pairs. So this is redundant, which should be eliminated. Is this clear?
Yes, sir.
One more typical example you can see here, though it is a bigger group, but that has to be eliminated because all the elements of that group are covered in some other groups. Like this, what you have to take. You should not form that middle one, middle one chord, right? So summary of the Karnaugh map method for simplifying Boolean expression. Already I have explained it, how you should do it. This is one more example shown here. You can see this is one pair, one chord, then two different chord and one pair, and you can get the answer, right? I think this I have given as a homework. You might people have already done this, right? Now the SOP expression, one more expression is given here. You can see how we can do the grouping, right? The different ways in which you can do the grouping is shown here. Don't care conditions already we have explained. Don't care wherever possible. It is, you can see here, only you can form this particular what chord. You need not again form one more chord of these four x. X forming or groups of all x is not mandatory. What is mandatory is all one should be covered. All your doubts regarding K-map should be cleared in this class. That's why I am doing this slideshow. Once again, I am repeating the same. Don't care condition, as I told, whenever you want to form a bigger group, you consider x as 1, otherwise ignore the x. That is a simple thumb rule that you should remember, right? So this is what is there, because you can see here there is only single 1 present here and rest all 0 and the rest are x. So this is what you get. Now here, is there any possibility of forming a bigger group? Yes. Single
No, sir.
1 is there. Can we combine this one with here 0 is there, here 0 is there? So it cannot be combined with anything else. So what we need to do in such case? Encircled, isolated 1. So what will be the answer for this case? Though we have the x is of no use, what is the answer?
A bar, B bar, C bar, D bar.
A bar, B bar, C bar, D bar. I hope it is clear. Some of you have not understood this, how to write the product term corresponding to isolated 1. This is what we'll get, and this is the answer for that. A bar, B bar, C bar, D bar, give it to an AND gate, you will get the Y implemented. Right, this already we have done. B, C, D answer you have got, right? So this one we have shown determination of minimal expression using essential prime implicants. Now what do you mean by implicants here or prime implicants here? The product term what you will be getting from K-map is called as prime implicant if it cannot be combined with another term to eliminate a variable, right? Whatever product term you will be getting from the K-map, you can call that as a prime implicant, right? But what exactly you mean by essential prime implicant? Now in this example, can you tell me what are the prime implicants? When they ask you to find all the implicants, prime implicants, all groups, whether it is redundant or irredundant, all groups you should form, and whatever product term you get for each group, that is called as a prime implicant. But some are not required, some are redundant. Those should be eliminated, and remaining are called as essential prime implicant. I hope it is clear the difference between prime implicant and the essential prime implicant. All the product terms, whether it is redundant or not, whatever group you form, whatever implicants you will be getting, those are called as prime implicants, and only those which are essential, right, which are not redundant, those are called as essential prime implicants. I hope it is clear. Many a time they will ask, write all the prime implicants from the K-map and identify the essential one. I hope you will able to do this. Is that clear, the difference between prime implicants and essential prime implicants? Now you can see here. Here we have formed two pair. This is one pair. This is another pair. So corresponding to this, we got implicant as A, B, C bar. Corresponding to this, we got implicant as A, B bar, C bar. But these two pairs are not required because we can combine them by one bigger group, and we get this as A, C bar. So A, C bar is called as essential prime implicant, whereas all the three are called as prime implicants. I hope it is clear, difference between essential prime implicants and the prime implicants. Yes?
Yes,
Is
sir.
it clear?
Yes, sir.
Yes, sir.
If you have any doubts, you ask. Right, already I have covered everything. Again, I am telling it is just like a revision of K-maps before we proceed further. Right. All of the prime implicants already I have told what is a prime implicant, and you can see here minimum solution what you are getting, that minimum solution will be using essential prime implicant. These are essential, but actually you can see there are different. You can form one chord like this, another chord, all these different things are there. So all the groups what you form, whether they are required or not, those all are called as prime implicants, and only those are required to get the minimum SOP solution, those are called as essential prime implicants. I hope it is clear, right? So again you can see here also it is shown what are essential and other prime implicants. Using essential prime implicants, right? Determination of minimum SOP using essential prime implicants. The same procedure what we have used, you should do it. So choose a min-term one which has not yet been covered, like how exactly you should do. The grouping is explained step by step here. Find all ones and x adjacent to that min-term. Check n adjacent squares on an n variable map. If a single term covers the min-term and all of the adjacent ones and x, then that term is an essential prime implicant. So select that term. Like this, you should repeat the process and you should find all the essential prime implicants and find a minimum set of prime implicants which cover the remaining ones on the map. This is the actual what you can say flowchart for the K-map method. All of you should go through it. This is also important. Many a time they will ask, with the help of flowchart, explain the K-map method. So whatever I have explained just now is put it in the flowchart. Choose a one which has not been covered, find all adjacent ones and x. Are there chosen ones and its adjacent ones and x covered by a single term? Yes, then that is essential. No, then again repeat this process till you cover all the ones. And finally, you should find a minimum set of prime implicants which cover the entire expression. This is very important. Whatever I explained, the same thing is put it in the form of a flowchart. Just go through it. It is there in your textbook also, and it is self-explanatory, right? That is what is about the K-map method. Almost all the examples we have solved on the K-map. These are some of the other examples. I think already I have covered these also. These examples are already covered. If not, you can just note down this and you can do it. Such kind of examples also I have told how you should do the simplification using K-map, right? These are from previous year question papers and some standard examples shown here. I think most of these already we have done. If some of these are not done, you can take down and you can try to solve these also. Right, here are some of the SOP equation with don't cares. These are from the VTU question papers. right? If out of this, if anyone is not done, you can just have a screenshot of this. You can take and you try to solve. Just take the screenshot if you are using mobile, or use the snipping tool to take this screenshot in your laptop, and you can solve these examples also, right? I think these already we have done. Okay, that fourth one you can take it. F4 of xyz equal to m0 dot m5. So how this should be done? This you have to do it as a homework. How it should be done? This is equivalent to what? Yes? This is equivalent to what? Are tell?
Pi,
Pi m of
0,
0,
5.
5.
0, 5. Yes? M0 dot capital M is max term, small m is min term. So you can do this also, right? This you can do it as a homework. See, here are some other examples. You can take again screenshot of this. All these examples, if you solve, definitely you will be expert in K-maps, right? Take the screenshot and try to solve, right? Don't do this homework just for the sake of doing. You should understand the concept. That's what you should do it. And you can cross check your answer, right? You need not share your homework every day to me. For your own satisfaction, you should do it. If you have any difficulties, if you are not understanding anything, yes, always you can ask me. I'll be there to help you or to guide you. Okay. Hope you have taken screenshot of this also. Yes. All these, whichever are not solved, you try to solve it. If you solve more number of examples, definitely you will be expert in this. See here also some more examples are there. There is no limit to the creation of problems, and you can get the solution for everything. You can create problem on your own also, and you can try to find the solution for the same. Okay, that's what the K-map method is. I hope all of you understood the K-map method. Any difficulties in the K-map method? Yes. This what that flowchart I told for the K-map method, and finding the essential prime implicants and non-essential prime implicants is shown here. This is what the explanation for that flowchart. This is important one. You need to study this. You may get this in your exam, so you should be perfect in this flowchart and the explanation for that flowchart. What is that steps? The steps used in K-map are these, and this is how it can be represented in the form of flowchart. Right, these are the steps used, and this is the K-map. And one example is shown here to differentiate between what is the minimal solution and what are the prime implicants and which are the essential prime implicants. Right, so these pairs, chord, octets, everything already I have covered. Here also there are few examples you can see here. So any doubts? If you have any doubts, you can ask me. Yes, I hope all of you have understood the concept of K-map. Yes?
Yes, sir.
Okay, so before we proceed further, I want to give two important examples you need to solve. You can just take down this. And these examples have appeared in September 2020 examination. Right? These are the two examples. Those are appeared in the September 2020 examination. You can take down the first example out of this. Right, a switching circuit. Yeah, in fact this is there as a exercise problem in your textbook. These two important examples they are asked in the September 2020 examination. You can just take down this first one. A switching circuit has two control inputs, C1 and C2. Switching circuit has two control inputs, C1 and C2. Switching circuit has two control inputs, C1, C2. comma, two data inputs x1 and x2, capital X1 and capital X2, two data inputs x1 and x2, and one output z, and one output z. The circuit performs one of the logic functions. The circuit performs one of the logic functions such as OR, XOR, comma, and, comma, EQU, or XOR and EQU. EQU for control input combination, for control inputs combination, for control inputs combination, C1 C2 as C1 comma C2 as 00 comma 01 comma 10 comma 11 respectively. Derive the truth table for Z. Derive the truth table for Z. Use K-map to find. Use K-map to find. Use K-map to find minimum AND OR gate circuit. Use K-map to find minimum AND OR gate circuit. AND OR gate circuit to realize Z. AND OR gate circuit to realize Z. To realize Z. Yeah. The problem statement is big, but the solution is very simple here. Can anybody try to analyze this? What exactly is given and what you need to find here? Yes? Anybody? Can anybody help me in solving this particular example? Yes. Yes, Sahil, can you help me? Yes? Yes, Sahil. Tell me. Yes? Sahil, are you there? See, people are only, I think, present for the namesake. Okay. If you are not interested, no need to attend the class then. Yes, Shreya, can you help me?
Yes, sir.
Yes. What is the problem statement? How do you go about this? I'll just explain what you need to do. You have to solve this problem. Right?
Yes, sir.
Just tell what you understood from the problem statement.
It has two inputs. The data.
Read properly. They are given. You have to design one circuit. Say, assume that this is the circuit. Okay. What is it?
A switching circuit has two inputs, C1 and C2.
Two control inputs. Okay.
C1 and C2.
And C2. Fine.
To the data inputs X1 and X2.
I think you have written it wrongly. A switching circuit has two control inputs
C1
and two data inputs X1 and X2. These are
and
correct.
yes, sir.
Switching circuit has two control inputs C1, C2 and two data input X1, X2 and
one output Z.
one output Z. Okay. Next.
The circuit performs one of the logic functions
Okay.
such as such as or
or
XOR
XOR
and
and
EQU.
EQU. Four operations it is performing. Based on what?
For control input combination C1 and C2
As
as 0 0
0 1 1
1
0
1
1.
1 1.
Means what? When C1 and C2 are 0 0, it performs OR operation. When C1 and C2 are 0 1, it performs XOR operation. Right? 1 0 AND operation, 1 1 EQ operation. All these operations will be performed on what?
Truth table.
All these operations will be performed on what? Based on C1, C2,
Okay, C1, C2.
either OR operation of X1 and X2 or XOR operation of X1 and X2 or AND operation of X1 and X2 and whether X1 and X2 are same. EQU means if they are same. Equivalent operations. Is that clear? Now for
Yes,
this
sir.
you have to write the truth table. Right? So
Yes.
how to write the truth table? Richa, can you tell me how I should write the truth table now?
No idea, sir.
You understood the problem statement?
Yes, sir.
Just now your friend has explained about the problem statement. Have you understood?
Yes, sir.
Okay, now if you understood that, it is easy to write the truth table for this. How we should write the truth table now? How many inputs are here totally?
4.
4 inputs. And how many output?
1 output.
So how many input combinations you will have in the truth table if you want to write? If you want to write the truth table, what we should do now? I have to write C1, C2, X1, X2, and
Z.
the output is Z. Is that clear? C1, C2, X1, X2, output Z. Now, how many inputs are there totally?
4 inputs.
4 inputs. So, how many input combinations you will get?
16.
So, write those 16 input combinations. So, how do I write? 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, then 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, then 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, then 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and last you will get 1, 1, 1, 1. Is that clear? The 16 combination I have written here. These are the 16 combinations you will be getting. Now you have to write the output. Is that clear?
Yes,
All
sir.
of you, is it clear? Adnan, any doubt?
No, sir.
Is this clear? 16 combination I have listed.
Yes.
The next important thing is to fill the output column. How I should fill the output column? That is what is the first question they ask. Write the truth table. Right? Now how I should fill the truth table? Based on this and based on the inputs x1 and x2, you have to write the output. Now you can see here for the first 4 combination C1, C2 is what? 0, 0. Now the next 4 combination it is 0, 1. Next 4 combination it is this, and for the next 4 combination it is 1, 1, 1, 1. So for these 4 input combination, which operation you have to perform?
Or,
Because here both C1 and C2 are 0, 0.
or, sir.
Yes, okay, what happened?
Or,
So play. Yes, here C1 and C2 are 0, 0. So which operation you need to perform?
or,
Or operation of what? Or operation of what? Yes,
X1, X2.
X1, X2. So can you tell me what is the output for the first case? For all the 4, we need to do OR operation of this and this. So 0 or 0 is what?
0.
0. Next 0 or 1.
0. 1.
0 or 1.
1.
1 or 0.
1.
1 or 1.
1.
So we got the first 4 combinations. Now next 4 input combination. Which operation you need to perform?
XOR.
XOR operation. So perform XOR operation of this. 0 XOR 0 is what?
1.
0 XOR 0.
0.
0.
0.
0 XOR 1.
1.
1.
You should know the truth table of XOR gate. In 2 input XOR gate, if the 2 inputs are same, output is 0. If the 2 inputs are different, output is 1. Is that clear? Fine. Now next, for these 4 input combination, which operation you need to perform?
And.
AND operation. So 0 and 0.
0.
0 and 1.
0.
1 and 0. And 1 and 1. Okay. Now for the last 4 combination, what operation you have to perform? Equate operation. You have to check whether they are equal or not. What is the output for this case then? 0, 0?
1.
1. 0, 1?
0.
1, 0?
0.
And 1, 1.
1.
See, this is the output. I hope this is clear. Then finally you have to write what is Z in terms of sigma m. You write this is 0, 1, 2, 3, 1, comma 2, comma 3, 4 not there, 5, 6, 5, 6, then 7, 8, 9, 10 is not there, 11, 12, and lastly 50. This is the expression for Z. Right? I hope it is clear. This is the expression for Z. Now what you need to do? The problem doesn't end there. What they ask is, write the truth table for Z you have written. Use the K-map to find the minimum AND. You got canonical SOP. Now you have to use a K-map. How many variable K-map you have to use again? How many variable K-map you have to use?
4 very
4.
4 variable K-map. So you should have a 4 variable K-map like this. You should write what variables here? C1, C2, X1, X2. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then enter 1, 2, 3, 5, 6, 11, 12, and 15. Remaining are all 0. Right? Check now how you can form the groupings here. How we can form the grouping? Yes? How we should form the grouping? There are different ways to form the grouping now. I form one group here like this. Right? Then I will form another group like this. Then I will form one group like this. Then this one with this, or you can combine with anyone. And this is one isolated one. Finally, you write the what product terms from this and then draw the logic diagram using AND, OR, and NOT gates. I hope it is clear. This is an important example and very good example, in fact, to understand the concept of logic design. Is this example clear? Yes? Or tell me whether you understood it or not. If you have not understood anything, you ask me to explain once again. I will do that.
Sir, understood, but the board isn't clear.
Board is not clear.
It's very blurry. I mean, your video itself is blurry.
Just a minute, I'll check. Check now. Yes?
Yes, a bit clear now, but still, sir, we can't read the video quality. I guess you should change the send resolution in your settings.
What happened?
If you change the send resolution in your settings, it will be better.
Is not visible now?
No, sir, we can't read anything.
Check.
No, sir, it's getting more blurry.
More blurred it is getting. Okay.
Video quality is low, sir.
Sir, In settings, you have video option. In there, you can change your send resolution to 720 pixels.
Just a minute. Wait. Settings. Audio, video,
Send resolution.
720.
Yeah.
Check now. I have changed it to 720 actually.
Yeah, it's still blurry.
It has not changed, I guess. Send resolution 720. Receive resolution. Receive, okay. I can keep it any, no problem. I can click it audio only.
So check if there is some dust over the camera. Maybe because
Is this clear now?
no.
No. There are so many days there was no problem. What happened today? Check. Is it okay?
No, sir. I mean, it's almost the same.
Setting I have changed, but it is not taking. Okay. I hope now at least you should able to read it, what is there on the board.
No, sir.
Check.
No, sir.
No.
It's too blurred, sir.
Too blurry.
Hold on,
Check.
a bit better.
I will keep it far off bit.
So it was better in the beginning from this.